This is Lab 3, Black Hole. The purpose of Part 1 of this lab is to use code and GlowScript to calculate the mass of a hypothetical black hole using the position coordinates and mass of a star that orbits the black hole. The purpose of Part 2 of this lab is to calculate the initial velocity of a ship needed for the ship to leave the orbit of a planet, and so that the ship can get close to the black hole but leave its orbit as well. We will use the calculated mass of black hole in Part 1 and given mass of planet and the given mass of the ship to calculate the individual gravitational forces and the net force. The result of this lab should be a calculated mass of the black hole and initial velocity to obtain a desired motion of the ship. Some fundamental physics principles used in here are Newton's second law, or the momentum principle. We also use universal gravitation, which is negative gmm over r squared. And I calculated gravitational forces between the ship, black hole, and the planet to find the net force on the ship and planet. Then I used the net force and the velocity update equation and used the position update formula with that new velocity. Lastly, I used centripetal force, which is equal to mv squared over r, and a centripetal force is a net force that acts on an object to keep it moving along a circular path. Some initial values I used were the mass of the star, which is 2 times 10 to the 30 kilograms. The initial time was 0 seconds, and the change in time was 1 day, which is equal to 86,400 seconds. Another value that should be noted is the gravitational constant g. The system and surroundings. In Part 1, the system is the black hole, and the surroundings are the star and the rest of the universe. In Part 2, the system is the ship, and the surroundings are the black hole and the planet. Here's Part 1 of my code. First, I set the gravitational constant g equal to 6.67 times 10 to the negative 11. Then I set the following initial conditions: the mass of the star, the time interval, to be 86,400 seconds. Then I found the final and initial momentum using P equals mv. Then I calculated the change in velocity and the change in momentum. I calculated dp dt using the change in momentum slash change in time. Then I found the parallel component of the net force and subtracted it from dp dt to find the perpendicular component. Then I calculated the mass of the black hole using the formula F net times r squared divided by g mass of star. Finally, I found the average of the black hole masses by dividing the sum by the number of indices. Here's part 2 of the code. First, I set the initial conditions again. The black hole mass was set to be 1.099 times 10 to the 34 kilograms, which is calculated from part 1. A planet mass was set to be 9 times 10 to the 28 kilograms, ship mass was 7 times 10 to the 10 kilograms, and the ship speed was 2 times 10 to the 5th, 9 times 10 to the 6th meters per second. And it was calculated by guess and check. Then I used the formula F equals gmm over r squared times r hat to calculate the gravitational force of BH on planet, BH on ship, and planet on ship. Then I calculated the F net on the planet and F net on the ship using the individual gravitational forces. Finally, I used the velocity update equation to update the planet's and ship's velocity and position. Some errors were that we were assuming that there are no other planets or stars affecting the net force of the ship, which could result in an incorrect net force calculation. We also assume that the black hole and the planet have uniform density when this is not realistic and will also affect the net force of the ship. The result of part 1 of the lab is that the mass of black hole is 1.099 times 10 to the 34 kg. The result of part 2 of the lab is that the initial velocity of a ship should be 2 times 10 to the 5th times 9 times 10 to the 6th meters per second, so that the ship can leave the planet's gravitational pull and can orbit the black hole for a short period of time, but leave the gravitational pull of the black hole. We can see from the model in part 2 that the ship changes trajectory because it is influenced by gravitational force from the black hole. In conclusion, what does it mean? Force is the external quantity that other bodies put on an object, while momentum describes the motion of an object. The parallel and perpendicular components of force influence the parallel and perpendicular parts of rate of change of momentum. But the other way around is not true. The initial velocity needed for the ship to orbit the black hole is negative 3 times 10 to the 5th, 1 times 10 to the 7th meters per second. I found this by increasing the y component, so the ship, I found this by increasing the y component of velocity and decreasing the x component of velocity, so the ship could not break free. from the black hole's gravitational pull but could still break free from the planet's gravitational pull. And that concludes my presentation. Thank you.